Good morning all of you. So today we will discuss about the functions of operating system. The contents we are going to learn about the operating system, that is introduction, little bit introduction about operating system, then various functions of operating system. In functions of operating system we have a number of functions. From those functions we just discuss the process concepts, in which we are discussing process scheduling, operations on processes, cooperating processes, and how processes are creation and termination, how both two or more processes execute simultaneously. Then memory management. In memory management we discuss logical and physical addresses, how they are converted and how they are generated. Swapping in memory management, continuous allocation, paging and segmentation. So before going to the functions of operating system, firstly we know about the what is operating system. So operating system is a program that manages the computer hardware. That means operating system is a master program that controls and manages the all hardware devices like input output devices. Okay, so it acts as an intermediator between a user of a computer and the computer hardware. That means it acts as a intermediator, that means a person who understand the human language and the as well as computer language. So an operating system is a control program because it controls and manages the whole program and input output devices. Okay. So next is the functions of operating system. There is various functions of operating system. So first is interface between user and hardware. That means it acts as a interface mediator, interface media that makes a user to communicate with the system and makes a computer to communicate with the human system. Okay. So an operating system acts as a intermediator between the user and the hardware, because computer does not understand the human language. Okay. And on the other hand, human does not convert our input into 0 and 1. If you want to enter hello world, then you try to enter 0 0 1 1 0 0, that does not mean it comes to hello world. Okay. So operating system that converts hello world into a binary language, because computer understand the binary or machine level language. Okay. So peripheral management. Operating system also manages the input output devices management. Okay. So if you want to use a single printer with a number of computer devices in a networking, then which printer and which command is going to process first, that is managed and controlled by the operating system. Next is memory management. So memory management, whenever you want to request for a page or request for a file, then it's operating system function that controls the memory management. Firstly it goes to the cache, then main memory. If it does not exist in the main memory, then go to the secondary management. Okay. So it all over depends on the operating system. So main function of operating system is memory management. Another is process management, which is very important, because we want to use multitasking, multi-programming. How these multi-programming and multitasking is going to be executed? It only possible if operating system manages our number of processes. Okay, because number of processes going to execute simultaneously, then may collide each other results, each other processing, each other calculation. So every process execute independently, that could be managed and controlled by the operating system. Okay. Without the management of the operating system, we can't execute our multitasking, multi-programming. Okay. So if our processes, number of processes execute simultaneously, independently, then multitasking and multi-programming is executed simultaneously. So first is interface between user and hardware. The computer hardware does not understand the language by human to communicate with each other. Okay, so computer does not understand the human language, that means English language. It only understands binary language, which is 0 and 1, machine language, that is 0 and 1, or either assembly language. It also converts input and output according to the user and computer. Okay, wherever we enter the language, English language, then the function and main control of the operating system that convert English language into the computer and machine language in the 0 and 1 form. After processing, then main responsibility of the operating system that convert that 0, 1 or binary or machine language into a human language, that is a English language, so that human can understand what is the result and what is the answer after processing. Okay. So next is second is peripheral management. Peripheral management, because the operating system manages the working of different input output devices attached to the computer system. That means it handles and controls the various input output devices that is connected to the computer system. Different input devices like printers and scanners work under the control of operating system. There are various, while we are doing a networking, we have number of computers and single input output devices. Okay, so that control is managed by the operating system. Okay. So next is memory management. Memory management is a technique used by operating system to allocate physical memory of finite capacity to multiple request processes. Okay, while we are doing number of processes execute simultaneously, then operating system that control and manages which process store where and how, so that each and every process work independently, their results, their memory locations does not collide or collapse each other. Okay, so that management is important in process management system, or while we are doing multitasking, there memory management is very, very important. It protects each process from each other. Okay, if we can't manage the memory management, then each process occupy their different or another process memory, so that their results collide each other. So if the process does not protect from each other, each processes, then their results does not accurate. Okay, so it protects or it provides a satisfactory level as performance to user. It transparents the memory address for the programmer. Okay, we does not know how they are going to store, which process is as a store where and how. So it is the responsibility and control of the operating system how the memory is allocated to which process, so that they are working and execute simultaneously and independently without any confusion of memory storage. So next is process management. A process or task is an instance of a program in execution. Process is a task of a program in an execution. A single program, we have number of processes. Okay, so it is the smallest unit of work that can be individually scheduled by a CPU schedulers. To execute a process, we have number of schedulers like long term schedulers, short and medium. So that scheduler, CPU scheduler, is provided to the processors. According to the schedulers, processes are going to be execute independently and simultaneously. Through CPU schedulers, we can able to execute a multitask and multi-programming independently. Multiple application to run simultaneously, same thing as this. If you want to execute multiple applications at the same time, through process management we can able to execute the multiple application. Otherwise we can't execute the multiple application. Only single application, a single user is able to use a single operating system. So process management is very important for the operating system to execute multiple programming and multitasking. Operating system keeps track of number of processes waiting to get processed and manages the process of each and every processes. Okay, so while we are doing number of processes executed, then the main function and main responsibility of the operating system to manages that processes. Okay, so next we are going to detail about the process management, process concept. An operating system execute a variety of programs like batch systems, time sharing system, job and programs used interchangeably. Okay, a process is a program in execution. Process execution proceed in sequential fashion. Okay, while we are doing responsibility of operating system manages number of programs like batch processing, time sharing. With the help of time sharing, we can able to perform our multitasking and multi-programming, because in time sharing we just divide our processes into a time slices. According to that time slices, our process is going to be executed and independently without interrupting each other processes. Okay, and that process executes sequentially, not randomly, sequentially. So while they are divided into time slices, okay, their processes may contain and may stores their addresses. So that addresses should be stored in the program, okay, process control systems that contains program, counter, stack and data section. Okay. So what is the difference between process and program? Okay, program is just a part of the process stage. A single program must have a number of processes. One process is we going to store data, another process is going to store data in a stack and main memory, we retrieving their data and deleting something. So there is number of processes come in the single program, and a single program may invoke number of processes. Okay, so a program may contain a number of processes. Now while we are doing a process, there is number of stages come while we are executing single process. So there is 5 stages comes while we are executing our processes. First is new stage, then is ready, another is running, third is running, fourth is waiting, and fifth is terminated. There is 5 stages of execution of a single process. So new stage while we are admitted or entering our new process. Okay, there is a ready queue, or you can say a new queue where a number of processes waiting for execution. So new means that process is admitting into the ready state. In ready, we have number of jobs that are going to be ready for execution. After that, a process or job getting a scheduler, and then that process going to run. If they are, while process going to execute, they require some input output devices management or other storage or other calculation, then it goes to the waiting stage. While one process is going to waiting stage, then another process is ready, then that ready process going to running stage. First is in the waiting stage, then second comes in running stage. While the first process execute their input output system, then it again comes in the ready state. That means he is ready to execute next stage. Okay, so on the other hand, second process execute their process, and if their processing is completed, then it going to the fifth stage, termination stage. Okay, so on the other hand, second is terminated, on the other hand first is again get their scheduler and then again running their left processes and going to terminate it. So there is number of stages comes while a process is going to execute. In this way, simultaneously we can execute 2 or more processes simultaneously. So these are the 5 stages of a process. A new stage means that a process is going to be created, going to execute. Second is running stage, instruction are being executed. Wait stage, waiting for some event or occur. Ready, waiting to assign to a processor. Okay, that means our process is waiting for a scheduler for assigning. Then fifth is terminated, process has finished or completed their execution, then a process comes in a terminated stage. While a process going to execute, then their number of stages comes. That stages and their result is stored in a process control block. Okay, there is some memory where data is going to be stored. First is process stage, that means it shows either process is going to new, ready or running or terminated. That means in this we are going to store the state of a process where a current process is going to. Then second is process number. Process number means process ID, which process is going to, because if we have 5 processes, then each and every process have a different process ID. So process ID is going to store here, process number. Then process counter. Process counter stores the address of next process. That means first is going to execute, which process is executed after the first. That means process counter or program counter stores the address of next instruction to going to be executed. Now registers, these are the general purpose registers that stores our intermediate results. Memory limits, that means ki how much memory is, what is the base limit, what is the limited information is going to store in this. Here we are using the memory management system. Then there is list of open files and so on, so are stored in the process control block. All the processes in a single process stages and their process control, every information should be stored in the process control block. That process control block associated with each process. It stores process stage, process number, program counter, CPU register, scheduling information, which process is prior or not, memory management informations, and various input output devices functions, and list of open files. So that all information is going to store in process control block. So this is a process scheduling. A single process is executed from in these number of stages, and a single process may generate their child process. That means small and small processes is generated during a single program execution. When a single program is executed, a number of little or small process is going to generated. That little or small process is known as a child process, and where they are going to generated, that process or main process is known as a parent process. So this is a ready queue. In ready queue, there are number of processes going to ready for execution. Then it gets the CPU time, and here it takes a CPU time for execution. If in between they have require some various input output devices, then it goes to the input output request, and they again enter in the input output queue where we are waiting for input output devices. Okay, and then after their processing, they are again goes to ready queue. If the process gets the CPU time and their process is going to complete it, then it goes to the terminate state. But if their processes require some small processes, then it generate a child process, and child process can be generated by a command fork. Fork command is used to create a child process. Okay, then child process is executed. If their execution is completed, then child process is terminates and send their results to the ready queue for the execution in CPU. Okay, if a single process requires some time slices or time expired, then it comes in the time slice expired session and then goes to the ready state, and they get the CPU time and terminate their process. Okay, if a process gets the CPU time and they have interrupted by a prior process, then it comes into stage of wait for an interrupt. Okay, then interrupted processes come to this wait state. After the interruption occurs and their processing is completed, then it again goes to the ready queue and gets the CPU time and do their processing. After completing or their processes completion, then goes to the termination stage. Okay, in this way we are performing and providing scheduling to a process in which one is parent process, another is child process. Small processes that are generated from the parent process, that known as a child process. Then process scheduling queues. There is 5 scheduling queues. First is job queue, where all the process is waiting for the CPU time. Ready queue, where set of all processes residing in the main memory and ready and wait to execution. Device queue, where a process is waiting for a input output devices time. Okay, so process migration between the various queues. Okay, so one process is going to another, and there is a migration of processes. A single process does not stay in a single stage. Okay, they are moving from one stage to another and another to another. Then in this way a whole process is going to execute it. Queue structures, it may use linked list or circular list, because first they are stores the R address or next queue address. Another structure stores the address of next instruction. Okay, so that's why they are using linked list that links the one to another. They are not storing the consecutive memory locations, they are storing in the linked list manner. So how we are executing the number of processes simultaneously? So how, if we are executing our processes simultaneously, then how we are protect from one process to the another process? So that protection is managed in a process control block and using memory management. Only one process can activate at a time. Another will store in number of process stages. In program counter we store the address of next process. So one process is going to activate at a single time. Current stage of a process held in a process control block. Okay, so the process is going to execute it, that process is going to store in a process control block. Process needs CPU and number of resources. So if they are required number of resources, then it goes to the input output devices, then another process is going to execute it and comes in process control block. CPU time to different processes, that means each and every process is going to execute, they execute after getting their scheduling times. After getting scheduling time, then it will going to execute it and run one by one. Give pieces of information or resources to different processes or protection. That means that each and every resources given to the processes, in this way they are not collapse each other. So protection is managed by the operating system. Control access to non CPU resources. like memory mapping. Okay. So how we are execute the concurrency, how we are manage the concurrencing of processes, task that switches CPU from one process to another process. The CPU must save the process control block stage of the old process and load the save PCB or process control block stage of the new process. Okay. So in CPU manage the current process stage as well as the old process stage, and these stages are stored in a process control block. Okay. While one is going to executed and completed their process going to the terminated state, then old process again loaded into the CPU or main memory, then going to execute that the previous process that are interrupted by the current process. Okay. So context switching time is overhead. System does no useful work while switching. So overhead sets minimum practical switches time can become a bottleneck. Times for context switch is depend on hardware support. Okay. So in this way CPU switches from one process to another. While one process or process 0, there is two processes going to execute it. First is P0 or P01 process and P1. Here is two processes going to execute it, and that process is managed by the operating system. Process 0 is going to executed by getting their time sharing and time slice. In this time slice going to execute it, then interruption is called, and another process want to execute their process, they get their time slice, then first process is interrupted and going to store their intermediate or in between result into the process control block. Okay. In this we are going to generate the two process control block, first for P0 and another process control block is for P1. While second is going to execute it, stages of P0 is saved into the process control block. Okay. Now stages save into the process control block 0, then second process is going to execute it. Okay. Then again reload the stage from process control, he is in the idle stage, then again reload the process control block 1, their execution is performing, then again interrupted by the some system call, then again save the stage of process control block 1. Okay. The number of stages come, in that case the process 1 is going to be in idle stage. Okay. Then again reload the addresses of P0 and rest of the process is going to execute it. Okay. So in this way two processes switches from one CPU to another, and CPU process switches from one process to another. Okay. So while one is going to execute it, another is stored in the process control block. So while process is going to execute it, they get the schedulers. There are different type of schedulers: long term schedulers, short term schedulers and medium term schedulers. Long term schedulers is also known as a job scheduler. That means overall job is taken over the time of CPU. So that's why we are called it job scheduler. It selects which process should be brought into the ready stage. Invoke very infrequently, and it may be slow the whole system because it overtakes the whole time of CPU. It controls the degree of multiprogramming. So multiprogramming can be performed or controlled by the long term schedulers. Short term schedulers, we can say it is also known as CPU schedulers.